Hey guys, Chapter 9, Section 4 video here for you. We are going to work today on how can I find the volume of a prism. So we are talking about volume now. We've done a lot of work with surface area, but volume is something a little bit different. So what is volume? Well, in this treasure chest that you see in this picture are a whole bunch of coins. The volume is how many coins fit inside the chest. Or for instance, in this gallon of milk. The milk inside, the gallon of milk, is the volume that fits inside this container. Have you ever seen one of these? It's called a water tower. It's where you reserve and save water for emergencies. Inside is filled with water. The volume is how much water is inside the tank. Or how about this? Have you ever helped pick cherries in the summer or been involved with that? When they fill up the bins of cherries, the number of cherries that fit inside the bins is the volume of cherries. So we are going to work on finding the volume of a prism. And here's something you need to know about volume. It's the measurement of the space inside. How many cherries fit in the bin? How many coins fit in the chest? How much milk fits in the carton? Those are all measurements of volume. So one way we think about it is we think about taking a shape like a box and cutting it into cubes and saying how many cubes are inside this shape. That would be the volume. I want you to think about that for a minute. How many cubes are inside this shape? Do you know? Well, there's lots of different ways you could kind of go about figuring that out. So here is a formula that would work for us. Volume equals base times height. Now I'm using a capital B on purpose. I put it in red so it would kind of stand out. Volume equals capital B base times height. And why am I doing that? Well, because B actually stands for the area of the base. What's the area of it? And H stands for the height of the prism. So if you can find the area of the base and the height of the prism, you can find the volume. We're going to try a problem and actually do that now. So here is our prism. It's a rectangular box measuring 6 by 8 by 15. We're going to find the volume. So if we were to fill this box up, let's say we're going to fill it up with sand. We're going to figure out how much could fit inside of there. Our job is to find the base first. Well, there's the base. It's in the shape of a rectangle. It's 6 by 8. And you know it's the base because it matches the top of the object. The base has to have a matching lid if it's a prism. So here's what we do. We find the area of the base, which is going to be just area of a rectangle, 6 times 8. And we're going to label that where the B is. So I'm going to draw a little arrow under the B, and I'm going to write 6 times 8, because that's the area of the base. Now, what's the height of our prism? How tall is our prism? Well, it's right here. It's 15 yards tall. So we're going to do 6 times 8 times 15. We're going to grab a calculator. We're going to have our answer. 6 times 8 is 48. So we just got to do 48 times 15, which is 720. So the volume of our object is 720, but here's what we say. We say yards with a little third power. Why the little third power? Because it stands for cubed. Remember, we're measuring how many little cubes fit inside of the object? Well, 720 yards cubed is what fits inside the object. All right, let's circle our answer and we'll try another one. So now we move on to example 2. Example 2 is this object. We're going to find the volume. If we were to fill up this prism with, I don't know, water or sand, fill it up with something. So here's the formula. Volume equals base times height. We've got to find the area of the base, but we need to know what the base is. Remember how it works with prisms. The base has to have a matching lid. Top and bottom have to match. So that rectangle, although it's sitting on it, is not going to be our base. The triangle is going to be our base because there's a matching one in the background, and there's a front and a back. There's a bottom and a top. So the triangle is going to be our base of our prism. So our job is to find the area of the triangle. Well, we know how to do that. Base times height divided by 2. So we're going to do 5.5 times the 2 inches, that's how tall the triangle is, divided by 2. What's the height of our prism? Well, we'd have to flip this thing over onto its base to picture the height. So the height's actually the 4 inches that you see over there. So we're going to be timesing by 4. Now we get a calculator. We do 5.5 times 2 divided by 2. That's actually just 5.5 and then we times it by 4, and we get 22. So our volume is measured in inches. We're going to say to the third power, and that's our answer, 22 inches to the third power. Or we say inches cubed, because it's like cutting up the object into little tiny cubes. How many cubes fit inside the object? Okay, your turn. You're going to try. Find the volume of these two shapes, or two figures. So we're going to start with this one first. I'm going to let you pause the video, and your job is to find the volume. Go ahead and try. All right, you ready to check your answer? Let's check it out. So volume is base times height. This time the base is going to be the square bottom, the 4 by 4 square bottom. So we're going to multiply 4 times 4 to find the area of it. The height of the object is also 4. It's 4 feet tall and 4 feet wide and 4 feet in depth. So we're going to do 4 times 4 times 4, which is 64. So our answer is 64 feet to the third power, feet cubed. And we circle that, and we got our volume. Okay, here's your second prism. Go ahead and pause the video and see if you can find the volume of this prism. All right, you ready to check your answer? So the trick on this one is figuring out where's the base. What is the base? Because we got to do volume equals base times height. Well, the base is going to be the triangular base because there's a matching one in the background. And to find the area of a triangle, we multiply base times height divided by 2. So we're going to do 12 times 5 divided by 2. The height of our prism is 9 meters. So we're going to be timesing everything by 9 when we're done. So we get a calculator and we do 12 times 5 divided by 2 times 9. That's 30 times 9, which is 270. So the answer is 270 meters to the third power. Okay, so tell me how you did. How'd you do on this problem? Did you get the right calculation? Did you remember to write meters to the third power? Did you remember the triangle is the base? If you made any mistakes, look for what that mistake is so that you're not repeating that later on. All right, so to kind of wrap up our video here, we're going to talk about surface area versus volume. It's important to know the difference. So if I had this nice cereal box and I said, how much cardboard do you need to make a cereal box? Is that a surface area problem or is that a volume problem? Well, the cardboard is the outside part of the box. That is surface area. That is not volume. What if I said, how many Skittles fit in this box? Have you ever gotten a box of candy like at the movie theater? So, how many Skittles fit in the box? Well, filling up the box with Skittles is a volume problem. Definitely a volume problem. All right, how about this? How many SpaghettiOs inside one can? If you were to try to figure out how many SpaghettiOs are inside that can. Inside is your giant hint. It's a volume problem. We're not talking about the outside. We're talking about the inside. How about this? How much wrapping paper do you need to wrap this present? Wrapping is on the outside of the box, not the inside. So that's surface area. That is a surface area question. All right, guys, so that kind of wraps up the video. Surface area is the outside, volume is the inside, and we got that nice formula, area of the base times height. Thanks for watching, guys. See you in the next video.